Okay, I'm just going to use this video to tell you a little bit about calculus and the first derivative. There are many different types of derivatives you can find and you'll learn throughout calculus. Each of them will give you different information about a function, which would be your f of x or your function y equals 0 or y equals x squared plus 2x, etc. It'll give you information about these functions that are pertinent to drawing it, as well as just learning more things about it. So the first derivative shows you the steepness of a function, or the rate of change, which is also known as your slope. Your slope always tells you how up and over you're going, or how down and over, etc. So there's different types of slopes. We have positive slopes, which would be when your derivative is greater than 0. So it's going positive. So an example would be y equals 2. A slope of 2 goes up 2 on your y and over 1. So that would be a slope of 2 on your line. Then you have negative graphs when your derivative of y is less than 0. That means it's going in the negative direction. An example of a negative slope would be negative 2. So that means you're going down 2 over 1 on that line. Okay, so negative 2, negative 15, all different kinds of slopes, they would be called negative when your graph is going downwards. Positive when your graph is going upwards. But what if your graph isn't going positive upwards or negative downwards? You would have a constant slope, where your derivative of y, your first derivative of y, equals 0. That means it's not going up or down at that point. That is commonly found at the maximums and the minimums of graphs. So maximum being the highest your graph goes on a curve, minimum being the lowest. So see, it goes up and then it stops curving, right? And then it goes back down. So when a curve changes, that means you're going to have a y equals 0 slope. So those are those three examples. There are different notations for your first derivative as well. So first derivative would be dy over dx, your derivative of y in terms of dx. The other form is your y derivative, so y to the 1. And then you have f of x, which is your function of x to the 1. Different forms of writing these, because there's so many different types of derivatives. Just to give you a quick example, you'd have your first derivative of y, or your second, your third, your fourth, etc. If you're doing it in terms of f of x, you would do f1 of x, f2 of x, f3 of x, f4 of x, etc. So they're just notations, just to give you a little information about that. We'll go into a lot more detail once I teach you the other derivatives. But just going back to your first derivative, it's going to tell you if your graph is increasing or decreasing, etc. So let's say we had this really weird curve here. The first derivative finds the slope at any point on your function or your graph. How does it do that? Well, it gives you the slope of a tangent line through those points. A tangent line is a straight line with the slope of that point. So this one's going this way. This one now is going downwards, which means this one's going to have a negative one. So this was positive, this one's going to be negative. This one's kind of evening out, but still slightly positive. This one has a very positive slope. And then this one's kind of evening back out to 0 again. So it's still positive, but just slightly. So it'll